Hey, hi friends. Welcome to today's video. So today we are going to discuss about solid principle. So this is one of the important questions that is being asked in the interview. And many of time we fail to explain this principles in terms of the real-time examples. This video is going to be a little long, but have patience and watch video till end to understand the complete principle, each and every word of this principle completely, and how we implement it in real-time example. And don't forget to subscribe the channel. This will really motivate me to make more and more videos for you. Let's come to the first principle, which is single responsibility principle. Like solid stand for five principles: single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. So we'll discuss each of them one by one. So let's first focus on single responsibility principle. Now, single responsibility principle states that a class should have a single responsibility. So I've created a sample project, and let's try to convert this sample project into a solid principle architecture. So I'll just go through what I have implemented. So this is like I've just implemented a list. So this is my comment view where I have a list, and then I have a view model. From view model, I'm just using comment view service, and comment view service is calling a network manager class, which is doing the network call, and then the data is coming back, and I'm just populating it into list, and I'm using open API, which is JSON placeholder dot typecode dot com. Okay, now let's try to focus on this class, network manager. Now here, if you see this class is right now doing two tasks. What the two tasks is doing? One task is it's making a network call on for you, and the second task what it's doing, it's decoding the data. Correct? So if I see in terms of solid principle, it is failing here because solid principle says that a class should have just one responsibility. Now let's try to break down this. So what I'm going to do here, as I told, I am doing two tasks. One task is making network call and another task is doing decoding. So I'll just going to create two classes which will perform this action separate. Okay. So let's create a first class. I'll call this class as, let's say, API handler. And I will create another class and I'll call it as response handler. Now my two classes are ready. One is the API handler, one is the response handler. So what API handler will do, it will call the API, and what response handler will do, it will decode the response which you will get from the actual API call. Okay. So just let's copy and paste these two here as well and here as well. Okay. Now here what I'm going to do, I'm going to include a dependency for these classes. So let's do it fast. Copy paste and response handler. So as I told you that one class will do the network call and one class will do the decoding thing. Okay. So I'll have a init method here, and this will take these two as a parameter. So I'll just give also the default value for these two, so that in the case if you don't uh, want to pass a parameter, it will just take the default value. So for this, the default value will be this, and for this, I'll just initialize and give the default value. Okay, so now my network manager class is ready, and now what we have to do, we have to remove this call from here. So this part will be actually done by my API handler. Okay, and API handler will not do the decoding. It will just do the network call and send the data back. Okay, and this response handler, this will do the decoding part. So here basically I will have this code, and all this code will remove from here. Okay, now let's further modify it. So I have now the URL, and then I'll call API handler dot get comments, and here I have to pass the URL. So let's have one parameter here, URL. So let me write it again. So API handler dot get comments. I'll pass URL, and see right now what is returning is returning me the model, but actually it will not return the model. It will just return me the data what it gets from there. Okay, and if the error, it will return me the error. So here instead of this return type, I'll change it to data type, and then here I'll return completion dot success. I'll return the data. Okay, so here basically I'll get the data. Okay, so switch result, now case dot success, let data, and let's just print the data for time being, and then let failure case, let error, and let's print error. We'll see later. So now this API handler task is done. It has called the API, it has got the data. After then what we have to do, we have to use the response handler class to decode it. Okay, so here what will the input type? That will be data, and it's going to return me the model. Okay, so now let's call this function from here in the success case, response handler dot get comments, and what you have to pass, you have to pass this data, and then completion, let's call it decoded result, and let's use a switch. Now again you have dot success, where you'll get your model, and this model you can pass using completion block. So completion dot success, let's pass the model, and you will have a failure case as well. So case dot failure, let error, let's pass the error in failure case. Case dot failure, and this will be error. Here also you can do the same thing. You can pass the error if there is any error. So here, like it's giving error. So let's just use self dot response handler, and now let's run it. And here we see our data as it is. So if you see, I haven't changed anything into my view model or my view, and it is working perfectly. Like I'm able to convert my existing network manager class to compile the S of the single responsibility principle. So here API handler making the taking the responsibility of calling the API, and response handler taking the responsibility of decoding the API. Okay, so now let's come to this to the next principle, which is called open close principle. So this one. Okay, open close principle says that a software entity should be open for extension but closed for modification. What does that means? That if let's say that if you want, if I have this class right now, network manager, okay, so if I have to implement something, I should not change the existing implementation. Okay, like I can extend it, but the existing implementation should not be changed. Now let's say that here I'm just making one API call. What I'm doing, I'm fetching get comments. Now let's say that if I have one more API call, so let's go here, and let's copy and paste this function. And let's say that here I have fetch users. Okay, now here instead of get comment, I'll just write fetch users, and here also I'll create one more function, fetch users. Just copy and paste it. Okay, now here also that means I need to create one more function here like this, which is actually going to fetch my user. Correct? If I build it, I think it should build successfully. But what I did, I changed my existing implementation of the network manager, and that where I am like violating the open close principle. Now, how can we solve this thing? And this can be solved in this particular case very easily using the concept of generic. Now, if you see this function, this is like expecting something of type comment model. Right now I'm fetching users, but obviously I will have something different. Like let's say that I go to my model and I create here one more model, user model. Okay. And it will have, let's say, three property, name and email. Okay. Now I will be using here user model, and that means here also I need to create one more method. So now what is happening, I'm doing multiple copy and paste. Okay, so let me just change it to user model so that it get run successfully. So fetch users, and here fetch users, so this should run now perfectly. Here also I have to do user model, and then same thing goes here. So here it's fine, and then here this is user model, so now this should be fetch users. Okay, and this should be also fetch users. Let's say that I'm calling the same API call. Obviously, like I'm not going to make the actual API call because there's no actual API call exist for this. It is giving me some error because I'm using identifiable protocol and don't have ID. So let's include a ID as well in this. Okay. Now let's build this again and see if we have any error. So we don't have any error. But what we did basically, we created a lot of copy and paste functionality in your actual project implementation. You might have 20-30 APIs call, and you are not going to do this, correct? That writing the same URL session multiple times. Now, to avoid breaking this open close principles, what I'm going to do, I'm going to use the concept of generic. Okay, now let's do this. So I just showed you like how I can run this without using the actual open close principle, but now I'm just going to delete everything whatever I have implemented. So let's delete this, let's delete this, and let's delete this as well. I will have some error right now because obviously when you run it from here, okay, because I was not calling the fetch user, but right now we don't have any fetch user here. Okay, so now how to solve this problem? So let's come back to our network manager, and instead of writing this as a generic to one particular API call, let's just call it as fetch request. Okay, and here also let's call it as fetch data or fetch data, and here call it as fetch models. Okay, now instead of typecasting it to a generic like to a particular model, let's typecast it to a generic object. Okay, so what I will do, I'll convert this to a T type. Okay, now from user, like whenever a person will call this API, I'm going to expect a parameter of like type, like which type he wants to use for this particular case. So and also I will take the URL from him because right now I'm hard coding this especially for this fetch request. So let's remove this also. I'll just put somewhere in my comment view service here. Let's just put it here. And then this will have a parameter like URL of type URL. And then this will also have something of a type. So let's say type T dot type. Like which type you want to decode for this particular API call. And we'll just confirm this to codable protocol. Okay. Now my fetch request is ready. Now let's go back to another thing. So here instead of calling get comment, I'll call fetch data. I'll pass the URL, and here this this is fine because I'm just getting the data and returning it back. Now the response handler, instead of calling get comment, I'll call fetch model like this. And then here, instead of decoding it to a particular type, what I will get, I already have the type from the user, correct? So this will conform to codable protocol. Okay, and we have to accept the type from the user, correct? So here we will take the type as well. So type t dot type. Okay, and then this result will be of type t, and this is also of type t. Sorry for my spelling mistake. So here this will be type dot self. Now let's build it one time and see where we are getting error. So here we have to pass this type. So let's pass this type here. Let's build it one more time. So this got succeeded. Now it's giving error in my service class. So here now I have the URL, and then now I will call network manager dot fetch request. Now which type you want here? You want of type comment model. URL, I have the URL, and then the completion is same, correct? Let's say that if I have something of users type as well. Right now I don't have, but let's assume. So here in this case, it will of user model, and then it will call here fetch request, the same thing, and then type will be user model. I have pass URL, and then let's say for I just writing user so that it makes a little difference. And then completion is completion. Okay. Now after this you have to write self because you are passing the type. Here also the same thing. Now let's build it one more time. So there's one more error right now, and this because when we are fetching the user, it is giving me a user model type. So let's just delete this line anyway. We are not going to call this API call. Now let's run this now and see if we get the data. And see, we are getting the data. But in this case, now see, I'm using the same network manager class to call two different API, one for the comments and one for the fetch users. And if you see the network manager, even if I add two or three APIs call, you are not going to change this implementation, correct? Because it is not dependent on any URL. Whatever the URL you will pass, it will take that. It is not hard coded for any particular model type, because what model type you are passing, it is doing it for that model for decoding. So this is how you can use open close principle perfectly to make your class closed for modification. Okay, so now this network manager is closed for modification. Whatever the API call you use from any of the classes, you are not going to touch this implementation, correct? So this was all about open close principle. Okay, so let's now go to the third one, which is Liskov substitution principle. So let's first go what is this principle basically. So this principle says that a subclass should be able to override the parent class method in a way that it doesn't break the functionality of the base class. Now the benefit of this principle is that when the code is interchangeable, it becomes more reusable. So there are 2 points which you need to take care while implementing Liskov substitution principle. The first one is that we should not implement stricter validation rules on input parameters than those implemented by the parent class. We'll see this example while implement it. And then the functionality should not break in the child class which implements the parent class. Okay. Now let's say that in the same example what we have made, uh, let's say that we have to support both online and offline mode. Okay. Now let's say that in the current example here, I'm always fetching from my comment view service, thinking that I always have the proper internet connection. Okay. But in that case, let's say that I have a database, and if there is no active internet connection, then I have to fetch the same thing from my database. Okay, now how we will do this? So first thing what we have to do, we have to implement the protocol oriented concept here. Okay, so what I'm going to do here, I'm going to define a protocol. Let's say, and this protocol will have the same these two methods. Okay, and this one as well. And this class, the comment view service, will conform to this protocol. And yeah, we have already implemented, so it doesn't give me any error. Okay, now let's create a new class which will actually be handling my core data. But in this example, I'm mostly focused on the solid principle, so I'll not go in the core data. So I'll read data from a local JSON file. Okay, so let's call it as database handler. And what the functionality of this class will be? This functionality of this class will be to fetch the data from the local JSON file. Okay, now let's define the class. And this class will also conform to the same protocol which we have defined here. Comment, and this class will also conform to the same protocol, comment view service delegate. So let's confirm. Now it will give error because we have not implemented the two methods. So let's implement it. Okay. Now here, instead of making the actual API call, what I will do, I'll read it from the local JSON file which I have here. Okay. So guard let URL equals to bundle dot main dot URL for resource, and the resource name is comments and extension is JSON. And let data equals to try data from the URL. So let's pass this URL. And third one is decode this data to model. So let model equals to try JSON decoder dot decode, and it has to decode to type this one from data. Okay, else that means something goes wrong, so we have to return a completion block with error. So completion dot failure, and here we'll go, let's say decoding error, and then in the success case we'll return the model. So completion dot success, and here it goes the model. So now my this class database handler class is ready. It is reading from, so okay, I forget to write the type here, and it's reading from my local JSON file. Okay, now let's go to the view model. So right now if you see, when the fetch comments method is getting called, it is actually calling the comment view service dot get comment. That means it will always call this particular method, the method which I have written for the actual API call. Now instead of having the comment view service class instance directly, I'll create the instance of this protocol type. So this will also help you later when you are going to write the test cases, because you can create a mock comment view service, and then you can confirm to the same protocol and then mock your API's call. Okay, so let's here write let, I'll just call it as service handler, and the second one as database handler. So see, the type is same because both class is confirming to the same protocol. Okay, so I'm going to write a init method. So we can give a default value for both of these, but why I'm taking init method, so that once you are going to write test cases for this command view model, In that case, you can pass your mock instances instead of the real instances. Okay. So here this will go as comment view service, and the next one, just copy and paste this and database handler, and this will go as an instance of database handler. Then self dot service handler equals to service handler, and self dot database handler equals to database handler. So now my both instance is ready. Now when the user or when we call this fetch comments, so first thing what we have to check that whether the internet connection is active or not. Okay, so let's write just one method, private function is connected. So I'm not going to write any actual implementation to find out whether the internet is connected or not. So I'm just going to return true for this time, so that it's one time we will check with true and one time we will check with false. And here if is connected, in that case we are going to read from your service handler class. Okay, and in the else scenario you will read the same thing, but instead of service handler it will go from database handler. And let's see if there is any error. Okay, cannot convert. Okay, I missed the return type, so it should be a boolean. Let's run it again. So I'm getting the list, and right now as I'm returning true, that means it is fetching from the actual API call. Okay, now let's return it false. And in this case also I am able to see my data. So this is what how we have implemented the Liskov substitution principle. So if you see this comment view service class, and if you see this my database handler class, now both is implementing a super class like a protocol, and they are not breaking the protocol implementation. Okay, so this is perfectly in line with the Liskov substitution principle. Okay, now how can we break it? Like what I will do wrong so that I'll say that I'm breaking the implementation of the Liskov substitution principle. So if you do any further validation at this level, let's say that what further validation I can do. Uh, for example, if here check further my internet. So let's say that here I have again a method to check internet connection. Let's say private function is connected, and it returns a true Boolean variable. Now here, if before making this network call, if I am further checking the condition again, now this check is different from this implementation, because here you are not checking that your network is connected or not. That means you are breaking the principle that you are changing your implementation in your child classes. So whatever the condition that you have, that should not come into your child implementation, that you have to keep in your super class implementation. So that's what the Liskov substitution principle says. So here we are breaking the precondition requirement, because that here we are checking that if the network is connected, then only let's make the API call. Okay, so this should not be done in accordance with the Liskov substitution principle. Okay, so now let's come to the next principle, which is called interface segregation principle. So this principle basically says that we should not force any client to implement interface which is irrelevant to them. So in this case, let's see how we are forcing our database handler. Now let's say that in our example, we want only the comments to be saved into our database. We don't want user data to be saved in our core data or anywhere. But in this example, what is happening? that database handler is conforming to command view service delegate interface or protocol, and it we are forcing it to implement both the method, and in this case the user's implementation is empty. Now how we can improve it using interface segregation principle? So what I'm going to do here, let's go to this delegate and let's create, instead of one, let's create two protocol here. So one and two. Okay, and let's delete this one. Now I'll call this as, let's say, comments delegate, and this one I'll call it as users delegate. Okay, now I have two delegate with me. Now this will implement or have a fetch users method, and this will have a get comments method. Now my database handler needs only comments delegate, correct? And then we can delete this method from here. So this is now fine. Now let's come back to here. Now our comment view service needs to implement these two methods. Now one way can be that we write this, that it confirms to comments delegate also and it confirms to user delegate also. Okay, which is fine here. We are confirming to both the protocol and implementing both the method. Now let's see what is happening in our view model. So here we have created service handler which was of type comment view service delegate. Now we don't have this protocol. I have deleted it, and same thing goes to database handler. So obviously this I know that this I will confirm to comments delegate. So this I change to comment delegate. Same thing goes here, and let's build it again. So this error will go. Now service handler needs two methods because I in when the internet is there, I want to fetch the users also and I want to fetch my comments as well. In that case, what I have to do, I have to create two instances, like one instances of user delegate and one instance of comments delegate. But let's say that if you have three, four protocol like that, so obviously like it will become unnecessary multiple object here. Now to solve this, we have a concept called protocol composition. That means we can combine two protocol and name it as a new protocol. So what I'm going to do, I will just use the same protocol name what I have here. So I write a protocol, and this protocol will just conform to comments delegate and user delegate, this one. Okay, now if I build it, it's still having one error because now we don't have okay, this comment view service, what is it's asking. So let's go to comment view service. So here instead of these, what I will write, I'll just write comment view service delegate. Okay, now let's build it again, and it's got succeeded. Now, if you see how we have beautifully used this interface segregation principle to force our database handler, I'm not forcing now my database handler to implement something users method which it doesn't use. And this comment view service, this one, both the methods. So here we are confirming to both the comments delegate and the user delegate. So this is what a interface segregation principle tells to us. Now let's go to the last principle, which is called dependency inversion principle. Now, what does dependency inversion principle basically means to us? So this principle says that a high level thing in our app, like any class or view controller, should not depend on lower level things. Okay, let's say that, for example, in my case, I have a network manager class. Now here what is happening, that here it is directly depending on API handler class and response handler class, correct? Now let's say that if you want to write the test cases of this network manager class, okay, you cannot write it because in that case it will call the actual API using this fetch data API handler class. Okay, now how can we avoid this? So this can be avoided again using interface or protocol. So here let's define a protocol. I'll call it as API handler delegate, and this will have the same method. Okay, and this class is going to conform to this delegate. Now what I changed? The implementation wise nothing got changed, only instead of having the concrete implementation directly in my API handler class, now it's conforming to API handler delegate and then implementing the method. Now how it will help you that when you are going to write the test cases, obviously you are not going to call actually URL session. You will mock something in some way using some third party library or writing your own code and fetching data locally, or you'll do something. Now here, the network manager class, which is directly having the API handler dependency, instead of this, I'll write here delegate. Okay, and same goes here. So in your actual call, you will be creating an API handler object, but when you are going to write a mock or you want to write your test cases, you will not create actual API handler. You will maybe you will implement something like mock API handler, which will not call the actual API call and do something locally in your system. I don't want to change this, but we can change this also. Uh, let's say that I'll just copy this and I'll call it as response handler delegate. And let's copy and paste this method as well. And same thing goes here and here. Now, what basically we did here that now if you see at this level, the network manager class, it don't directly depend on the API handler. Instead, it is talking through a interface, which is API handler delegate. So that is what this dependency inversion principle say, that the high level component should not depend on the low level component directly. Okay, instead it should depend as an abstraction of that component. Abstraction we can achieve in Swift or iOS through protocols. Okay, so that is what we did here. So if you see in this complete example, how I implemented solid design principle to segregate or to make my code much cleaner and reusable and testable. Okay. So if you really like this video, then don't forget to subscribe the channel and please do like, comment, share and subscribe. And thanks for watching.